Cool. I think we're live now. Welcome everyone to the Bioprotocol Hackathon Showcase. We have a couple amazing teams today. 3 teams are going to present about a live demo and walkthrough of what they've been working on. We'll also talk about some of the other teams that have been progressing, building bioagents in the hackathon, and also the state of AI science in general. I think there's a few discussion topics we can bring up, and because in the Web 2 space, the past weeks have been pretty incredible with the amount of releases, and I think there's some renewed interest in AI applied to science. So really excited to kick this off. The order of operations here, we have Science Stanley presenting about the Rare Compute project, and then we'll have SpineDAO presenting their HackGrid project, and then wrapping up, we have ValleyDAO, Morgan Richards from ValleyDAO presenting on what they've been building. So really excited. Let me, as well, my co-host Eric, who's also been instrumental in organizing and running the hackathon. So shout out to Eric and appreciate you. With that, let's get right into it. Get into the code, get into the projects, and yeah, so Science Stanley, please go ahead and maybe introduce yourself and the project.
Hey guys, so happy to be here. This hackathon has been so much fun. We'll say just a little bit about myself and the project we've been working on, but also have to say I grew up in Palo Alto and was a pretty young person around the 90s when we had the early internet bubbles. And I remember this period of time where I was still in grade school and like everyone was trying to learn HTML, talking about websites, trying to wrap their head around like what websites were, why you needed one. And I remember a feeling of feeling like I was missing out a little bit. And then by golly, are we living through something similar? It really has been palpable, like the rising conversation about agents. And yeah, in science particularly, been so exciting to see how agents can help scientists. And yeah, scientists increasingly excited about access to agents. Um, and then yeah, I'm in Web3, go by kind of goofy name, Science Stanley, do a lot of communication about why I think DeSci is so important. But yeah, day to day, I am a computer scientist and I design and build high performance computing systems for scientists. And so, yeah, it was really fun to kind of look at the partners I work with, kind of, look at their process broadly in say like designing a new medicine. And then, yeah, looking for the places where, the human intelligence isn't being put to a good use, where we could usefully tag in some machine intelligence. And so have a particularly, I think, kind of fun example of where we think AI is going to be accelerating science. And yeah, we'll have a full hosted demo because this is actually a very cool system where you dump papers in one side and then data sets come out the other side that contain proteins. And not just any proteins, but the proteins that are relevant to the science that is described in the papers. Why do we care about proteins? What are protein data sets for? How would we use them? Well, we do care about proteins because we are all made of proteins, and proteins are very literally the actors of life. Almost any biological process happens or is mediated through proteins and their interactomics. Almost any disease happens because some protein is doing the wrong thing or doing the right thing too much. So by understanding and exploring the dynamics of proteins, we can, in many cases, create interventions for patients. And one of the things that is kind of new that we can do that is very exciting is this set of techniques that is starting to be called in silico directed evolution of proteins. So yeah, quite literally, we're using machine learning models that have been trained on the data set of all imaged proteins. to be able to understand how, when, where proteins evolve. Because proteins aren't just these like incredible mechanical devices, they are evolutionary actors. Proteins are designed not just to do what they're supposed to do, but to react to the environment, to adapt to changing circumstances. So we can actually tap into that sort of linguistic information about evolution and then ask a protein to show us how it could evolve. What's interesting though is that proteins can evolve in many different directions. So in order to perform this synthetic evolution process with intention and direction, we need these tuning sets. So you might think of them as like flavors of a protein's function. We also can liken this to things like language models, where if, let's say, you have the example of a certain person speaking, you can tune a model to speak more like them. Similarly with proteins, if you see right here this table, which contains a set of proteins that have a certain type of what we would call a binding pocket. So that's a place where a protein can be activated by another molecule. By taking this data set of proteins with a very certain type of known binding pocket, we actually get out the other end a tuned model that understands binding pocket dynamics better. So for example, this would be a protein, and then you can see it has a little binding pocket that's being fit to right here. So this AI, because it's been trained on this set of proteins, is able to identify that binding pocket. And so this is a very cool piece of bioinformatics. And then, yeah, at Rare Compute, we're using this to actually design novel medications. So we might take a target, like say a gap junction connexin, ask the system to generate a protein that fits it. But yeah, again, one of the recipes is these kind of custom data sets where we've maybe captured proteins that represent thermostability, or we've captured proteins that represent interaction with a quantum field. And sort of with that flavor, sometimes I think of it as like a painter's palette. You can sort of mix this little bit of this, a little bit of that, and then actually get a custom molecule that actually, tackles the problem. And yeah, it was very exciting. Last year, our nonprofit Rare Compute found a new peptide that yeah does work on gap junction connections. Those are the proteins that allow our cells to kind of talk to and interact with each other. And it is currently undergoing wet lab validation. This has led to a lot of interest in designing other proteins and bringing them into the wet lab. But yeah, there's this one step where we have to read through every paper about the subject, find every protein, go get them, organize them into a data set, do kind of quality assurance work. And then that is the job that we've given to this agent. So anyway, getting to the demo, and then forgive me for feeling a little, I do just have a little bit of an obsession with protein dynamics. But yeah, here is our agent. Running here on the screen. So input is you just dump a bunch of PDFs into a folder. It is maybe a 5 or 6 step agent where each agent does a different step of the paper reading. We have a great video where we actually worked through the set of steps with a Cedars-Sinai oncologist. So we were able to actually get from him how he reads a paper, how he decides what paper to read, how he goes through paragraph by paragraph to select paragraphs of interest, how he does deeper readings. And then, yeah, we've also been working with him closely to tune and reinforcement learn this system. So you can see over here, it's running, it's finding paragraphs. Inside the paragraphs, it's finding proteins that could be interesting for immunotherapy. And then, yeah, the final step is it through the MCP plugin we've built for the hackathon, actually does reach out to the PDB data bank, gathers the proteins, and creates one of these little tables that we can use to tune our systems. So anyway, yeah, has been really fun, and I think we're looking to push the code and have it demoable for next week, so that if you wanted to go on, dump some papers about proteins or immunotherapy, and then get one of these nice data sets ready to use at the other side, you'll be able to get involved. Also, just so excited to take this around to a bunch of our partners. I think working within just the bio ecosystem, Long COVID Labs and Quantum Biology Research Institute both have some really cool work being done with proteins that will have applications here. Beyond that, though, there really is like a huge demand for this kind of work. At the Rare Compute Foundation, we have kind of more inbound than we have capacity. So quite literally, I really feel like this agent will let us take on, more projects. That's just for us. We're really hoping that this, the other agents for the hackathon that it can plug into, just going to be really exciting stuff. So, Eric, thank you so much for kind of organizing this, letting me talk a little bit about what we're doing. And yeah, just can't wait to hear about the other projects and get this hackathon over the finish line in a month or so.
Yeah, thank you, Stanley. I had a question of my own, or maybe a discussion point is, I think about the different layers of like kind of a quick way to think about the abstraction layer between these agents is that you have the inference model that could be O3, it could be a scientific foundational model. So you have the model, and then you have the agent framework, which is could be ELIZA, it could be others, and then you have plugins to those frameworks that they could be called tools or plugins that give each agent more functionality, and those plugins could also have a specific model attached to them, such as a protein interotomics specific model just for that plugin. Maybe if you could talk a sec on building the agent, like how you think about those three, kind of the model, the base model, the agent framework, and then possibly plugins.
Man, it's such an exciting time. Really just at the intersection of those objects and like how they're going to come together, be expressed, be shared. Um, I started in machine learning doing computational linguistics for Google's localization group about 15 years ago. And this was in the very early moments of kind of interconnecting multi GPU nodes in the cloud. And quite notably, it was pre-Docker. So I remember clearly the pain of not having Docker. And I like to think that it was that pain that led us to Docker. So I really feel like with these primitives that you mentioned, we're in a similar moment. And it's not Docker that we're needing to build, but it's some way of portabilizing agentic memory configurations, which are sort of like this aggregate presentation of all the components needed to run an agent: the models, the prompts, the tunings, the RAG, the interface servers and protocols. And yeah, it's quite fascinating. And I think we are going to need to have some standards so that these things can be made portable. They can be kind of shared from one system to another. And then also we have so much to learn about where the value is. Like, because just for example, like you say, Sean, with these protein models, we're actually discovering the tuning sets are much more important than the base models. That actually protein models are remarkably sparse, and a lot of their output does come from their tuning layers or their lower layers. So may very well be that for protein agents, the tuning layers are much more important than the models. Similarly in other domains, it could be the reasoning quality. But really, like enumerating what a given agentic memory configuration is as an object, then figuring out how do we optimize on a case by case level. What an exciting thing to be part of, like learning about, you know?
Totally. Yeah. Thank you for sharing about Rare Compute. Now let's switch over to Siddharth and can present about the Spine DAO project.
Hi guys, we are from India.
Hello, welcome.
Yeah, sure. Let me share the screen for a small presentation. Hi, Evan. We're Team Hagrid, and we're working on solving the spine DAO problem. The core problem we are addressing is how can we retrieve the valuable knowledge about spine-related health to help researchers and scientists develop non-surgical solutions. In a recent video by the co-founder of Spine DAO, it was mentioned that 90% of spine patients don't actually need surgery yet. Surgery remains the default approach. This highlights a major gap in knowledge dissemination and treatment innovation. We're from India. We firmly believe that the Indian data, especially from particularly in traditional systems like Ayurveda and Siddha medicine, is going to perform well. We are from a state called Tamil Nadu in India, a state rich in historical medical knowledge. And since Tamil, the language, it is one of the oldest living languages, we have decided to explore the ancient texts from Tamil. Okay, so we are building a system that mines historical and modern spine health text. We generate novel evidence based on event hypothesis, use a knowledge graph as the foundation for it. This will help consolidate ancestral wisdom and contemporary research to create a unified, intelligent view of spine health. Okay, the challenges we face. Now, the biggest challenge we faced was data availability. The text, especially the Tamil text on spine, is very scarce and undigitized. Most texts are in vernacular languages and stored physically. We found that translating Tamil text to English before processing often loses semantic meanings, especially in the medical context. We'll move on to the code for a quick demo. Data. So these are the actual data which we went to the physical libraries and took a photo of them. This is Tamil, by the way. The Tamil about the spine health. We use we use OCR. We use OCR to extract the text. Next, we put the OCR. We take the data. We put the data through entity recognition model to create nodes. With the nodes, we put it through a relationship mapping. We extract the nodes and map it to the relationship to give a knowledge graph. With knowledge graph, we can easily come up with hypothesis. We'll show you about the knowledge graph. So we were able to create this knowledge graph from a very small amount of data. From these knowledge graphs, scientists and researchers can easily create hypotheses of different types, which they have never seen before. All of these are related to spine, based on other things also, like back pain, how it relates to pain relief, how it relates to cancer, lack of muscle, etc. Coming back, so why does this matter? Access to alternative and non-surgical treatment insights that modern medicine may have overlooked, and more importantly, helping reduce unnecessary surgeries, improving patient outcomes, and lowering healthcare costs globally. So in our demo, we have used Camel AI and Open API for the name and entity recognition and relation text. For our main approach, we're actually planning to physically annotate the data to train the local models. We are also planning to fine-tune a local by LSTM CRF model for the name and entity recognition and the relationship mapping. We're actively reaching out to different institutions across to collect manuscripts which are really rare on Tamil medical corpus. Many institutions do not have soft copies, so we are taking the effort to scan and OCR these material assets. As we gather more data, we aim to fine-tune the encoder process, build a decentralized and interpretable knowledge graph, make it more globally accessible. That's it, guys. Thank you.
Wow, thank you. That's really cool. Yeah, wow. So how many books would you say you took physical photos of, and how was that OCR process? Was there any like issues with the actual software there, or did it just work great?
Yeah, yeah, sure. Actually, we went to the closest library. We were unable to find any books related to Ayurveda and Siddha. Ayurveda and Siddha are the traditional Indian medicine things. So it was very rare. And only sections of it were about spine. So we gathered the knowledge. It was about 8 books. Then OCR, we tried many OCR like ROLM OCR, which is primarily trained based on the South Asian text. Then for the sake of the demo, we have used Gemini's 2.5 Pro model, which does a really great job in translating and does. Now we get a digitized version. Then we use Camel AI for the entity recognition and stuff, entity recognition and the relationship mapping. We were able to get a good knowledge graph. I think with the increased amount of data, we can not rely on APIs and frameworks and fine tune the model assets. That's what we are planning for.
Great. We had one question from Albert. I know you're still working on like the fine tuning and imagine like an agent looking at the knowledge graph to maybe come up with hypotheses or alternate treatment paths. But have you tested like an agent looking at your knowledge graph yet, or not yet?
No, we are still in the process. We are yet to do it.
Cool. Yeah.
And Sean, can I ask a question?
Of course.
So I know that this project came from the Spine DAO team, which it's amazing to see hackers working with individual bio DAOs. I think that was a huge part of what we were hoping for going into this hackathon. So just want to say thank you guys for communicating and kind of working with the different teams who are here. One of my questions, I guess part of it is, why did you pick this specific project to work on? And, you know, as you're talking about some of the physical data annotations, as you're talking about going to libraries, that's a lot of work on your part. It's very much appreciated. Kind of what's driving you to do all of this? Why are you excited to be here?
So when we saw the hackathon from the DevFolio platform, this was the first established problem statement as was. Then we were considering different problem statements. We knew we had to do something hard, right? Longevity, everything was great, but this really goes deep into our past. And as we know, India has a lot of data in many different languages, in the Indic languages, but none of them are available publicly, and it's more valuable. So this is what drives us, and is still driving us to do the Spine DAO project.
And I know based on the project spec that's on the hackathon docs, the original idea from this project actually came from a 2015 Nobel Prize, where someone did exactly what you're doing, only perhaps a little bit less intensive, on Chinese medical texts, and was able to find an anti-malaria drug that was so significant that they actually were given a Nobel Prize for it. So it's amazing to see the work that y'all are doing, and just wanted to say thank you.
Thank you.
Thank you.
Yeah, thank you, Siddharth. Check out the chat. It looks like someone wanted to connect with you. If there's any other questions, I'll pause for like a few seconds to let anyone else in the chat ask a Siddharth question. Yeah, we'll have time for questions at the end too. So that, Morgan Richards, I'd love, thank you for joining us, and really excited to hear what Valley DAO is doing. And I know you have a few projects going on around AI within the DAO, and so super excited to hear about that and the hackathon progress.
Awesome. Can you hear me well?
Yes, we can. Excellent.
Okay, so Gunjan, our developer, is going to share his screen, and we're going to walk through a little bit of a live demo, something you should never do. But we've done it before, and it's worked, so fingers crossed this time. And yeah, in the meantime, I'm going to give a bit of an overview of what we're building, kind of the big picture goals of that, and then yeah, how we're breaking down that very large goal into slightly more digestible problems that we can start to tackle. So
even a 30-second introduction of ValleyDAO might be helpful to the audience as well.
Yeah, of course. So for those of you that aren't familiar with us, ValleyDAO are a climate biotech focused DAO. And so you might be thinking, if you've not heard of climate biotech, what the hell is that? How is bio solving problems in climate? Well, some of the best examples are, for example, you could use, one of the projects we funded actually is using yeast in a big giant bioreactor. So in the same way that you brew beer, we are actually brewing lipids. So like replacements for palm oil, cocoa butter, and these oils that may come from plants or other sources that may be unsustainable or have ethics issues related to them. And so these are ways in which that biotechnologies can actually address climate issues. But it doesn't stop there. We've got things like microalgae who can capture carbon and turn it into almost any chemical on the planet. We've got bacteria who can digest plastics or clean up toxic pollutants in the environment. So like radioactive waste or toxic spills that come from chemical plants. Bio can address all of these problems. And so what we have, bio at large, is just really a really broad and capable technology. And what we in the biotech space are all about is figuring out how can we use that technology for social benefit. And so that's kind of the big picture goal of ValleyDAO. And really when we started out, the biggest thing was, can we fund research in this space? Can we get a community of like-minded people who are passionate and care about this particular field of science to come together, fund the research, and see some of that actually have a tangible impact on the world? Well, we got pretty far on the first step, which was the funding side. And then, of course, comes the impact side. Can we actually translate any of these research projects into something that can have an impact on the world and the people around us? So that was something that has always been a core problem to us in the DAO and is a core problem to many people within the scientific industry. And so our particular use case for AI, and what we're working on in the hackathon as well, is actually looking at the business of science. And can we bring scientists up to a level where, one, they feel comfortable enough to make the leap from academia to entrepreneurship or industry. Two, that they're able to deal with the skills gaps or maybe the biases that they may have from the academic industry. And three, overcome some of the blinders that many academics have, which is, we're working on really cool, innovative stuff, and it's going to change the world. Well, it's not that simple, right? If it's going to change the world, if it actually has a place in the world, then it needs to be, unfortunately, it needs to be economically viable. And that is a completely different problem to solve than the problems that scientists are used to solving. And so our vision was really a platform that people could bring on their research at any stage, whether it's idea, proof of concept, or even if they've developed something, they've got IP, but they don't know how to translate it. So our vision was really to create a platform that could facilitate all of that. Now, AI wasn't the first instinct on that, but as time has gone on, as capabilities have just so drastically and quickly increased, we've really gone all in on AI and believe that we can really start to do some really interesting things. So our platform that we're building at the moment is called Flow, and it has features within 3 specific domains. So the first domain is the most obvious one, fundraising, right? All of these projects need financing somehow. And yeah, we wanted to see what we could do with AI to actually help facilitate the fundraising aspect. Of course, we fund from our own treasury, but we have a limited pool of funds. We cannot fund all of the research that comes in. So how can we actually help projects that maybe we don't fund directly, or at least not now? How can we help those projects secure funds so they can actually do meaningful work? The second pillar is the business development. So this is really like, understanding your target market, your customer needs, your competitors, being able to tinker and tailor different business models, work out different pricing strategies, marketing, all of the things that academia does not typically train you to do. And then the third pillar is technology development. Now, this is something that is maybe not as underserved as the other two, because researchers are actually pretty good at developing technologies. But what they're maybe not so good at, or at least from the commercial perspective, what they're not so good at is developing things that are that have an actual market, right? And a lot of the reason for that is that the research doesn't start out with a commercial objective, or it doesn't start out with a real world tangible application. It starts out with, okay, let's, for want of a better phrase, fuck around and find out. Let's put some things together. Let's try out some different experiments and see what we can learn from that. And that progressive learning leads us to ideas. It leads us to innovations and inventions that we can then find ways in which we can use to benefit people. But of course, when you do it that way, what you find oftentimes is that you spend a bunch of money and a bunch of years of research into something that just when you get to pilot or commercial scale, it's never going to work. And so our idea in the technology development space is, can we actually use maybe some of the insights from business development and from the needs of funders, or the kind of interests and appetite of funders? Can we use that to feed back to the research design process and actually help people design technologies and research programs that make sense, that have like an end customer in mind, and then use that to kind of create all of the steps? And so all of this to say, that's our kind of grand plan for how we intend to use AI within ValleyDAO. And we don't just want this to be like our thing. We definitely want this to be a thing that is accessible to all DAOs, but also just researchers in general that want to translate their work. So we're really keen on, this was one of the reasons we were really keen on engaging with the hackathon, seeing what other people are building and potentially collaborating. And yeah, really putting ourselves, challenging ourselves and seeing how far we can go with this. So I can't actually see, Gunjan, are you sharing your screen already?
Let's see. We might need to get him into the into the speaker section. Okay, there he is. Great.
Okay, nice.
Is it visible now?
Yes, yeah, I can see that.
Perfect.
Okay, so I'm not done talking yet, but I'm done with my whole spiel, and now we get to actually show you what we've been working on and how it all fits together. So here we have a example project that we created. This was an idea that we had in the Discord a few years back, and for the sake of testing our own capabilities, we wanted to see this idea never went anywhere. It was just a conversation, a few messages exchanged, and it was like wouldn't it be nice if? But of course, no one had the time or energy or even commitment to explore this further. So what we wanted to do was test our pipeline on this idea and see, could we actually make something of this? So the first thing that we developed is, if you hit the funding tab, Gunjan, is there actually any matched funding for this one? There is. Okay, excellent. So we created a fundraising database. So this is actually agnostic from, for example, private equity, but also government grants, like competitions, basically any source of funds that you could get to fund a research program. We put that all into our database, and we then use AI to be able to match your project details. So more specific on your technology, the field you're working in, the disruptive potential, to match that technology to the most relevant funding opportunities for that particular project. So you can see here, we've got a few matches already. The database hasn't been updated recently, so since Jan, so we definitely need to do a refresh of that. But you can see that there are some funding opportunities that are matched. Here, if we hover over the match score, you can see a breakdown of exactly how the AI is scoring the match between your project and the funding that you want to receive. You can save and bookmark them. What we intend to create in the future is also a application tailoring tool. And this is something that we've already tested in several different iterations. So it's actually a pretty easy task, but basically be able to rewrite a grant application based on the specific funding opportunity that you're applying to. So that's funding. But if we hit the technology tab, then we can actually see this pipeline that we created. So we did a demo of this. The full demo is actually on YouTube, so we can happily share that with anyone that's interested in a bit of a slower snail's pace demo. But here we have the kind of main first page of the technology design tool. So what it does is it prompts the user to answer a lot of very specific and sometimes strange questions to answer about a research project. But really what we're trying to do is understand the intentions, the goals that the user has, and then be able to use that to inform the technology design process. So you answer a bunch of these questions, which include must-have features, nice-to-have features, constraints, what TRL you're at, for example. Some of this is also AI generated, so you can just put in some small details and we'll actually expand on that for you. Then what we do is create these flow diagrams. So these are all automatically generated based on your technology. It assumes that it's at an industrial scale implementation already. So you can actually then break down the different processing steps, identify any risks or unexpected occurrences that might happen in your process when it's at industrial scale, and really start to design your research in a way that is conducive to the end goal, which is obviously a full-scale commercially deployed technology. We won't go into too much detail on these, but each step, it has a lot of detail on how it works. So you can expand on those. There's different inputs and outputs that you can see at each step. Obviously there's optimizations to be done here. But if we just skip ahead to the next page, so what we do from all of this is we identify next steps. So things that are likely to make or break your research. And so these are all AI generated again, but it uses all of the details from the questions that you've answered before, everything that we know already about your project. And these are the recommended next steps for literature review. Then we take these next steps, we run them through another agent, which generates these research queries. And you can see that some of them are color-coded and in groups. So the reason being is that we actually have this sequential research process. So we don't just send out 10 agents at the same time to do a bunch of random research and then try and fit it back together. What we're doing is actually constantly updating the knowledge base. And each time we're learning new things, then we're taking that into the next question, updating the next question with those specific variables that we found, and then asking that question to the second agent so that the second agent can get a lot richer detail and context each time. And this runs up to 10 queries in one run. We can extend that, of course, but for now we've limited it to 10 because they're quite expensive to run. And then when we hit next, you'll see some of the results. So the ones that are not dependent on each other get run in parallel. The ones that are dependent, you can see they're all waiting. So we actually need to go in, verify this result. So we'll read the report. I think this is just a demo one. So it's not the full research report. Do we have one of the full research report, Gundern? Maybe on there's a different project that we have a full research report on.
Most probably we don't have it right now.
Okay, no worries. And this is why you never do live demos.
Yeah. No, we don't have it ready.
You'll have to imagine and that there's a full report on here, but this is unfortunately the test version, so we limited the token generation. But usually there's a full multi-page report on here, lots of details extracted. When you're happy with that, you can then verify that result. So if we just want to test the verification. So you can reject it. If you're not happy with it, you can say why. You can deselect sources that the research agent has used and cited in the research. And then you can ask it basically to rerun this research, and it will do so. It will take into account your instructions, and it will remove or hide any sources that you don't want in the research. So you can actually exclude things. So that's great. Then if we just skip ahead to, so you can see now it's regenerating that one. And yeah, we have another one to verify. So we can just assume that that's verifying. And now it starts queuing the ones that are dependent on it as well. Do we have the research outcomes for this one? I guess not. Yeah, so usually what happens here when all of the research has been run, we'll have a list of research outcomes. So these are actually the key findings that we were looking for. In this case, we were looking for certain types of enzymes. We were looking for optimal conditions for cultivation of the microalgae and the parameters. We're also looking for which strains of microalgae we should use. So what it's doing is running all of these literature reviews in parallel to find you like the best or the most up-to-date information that you can get for this project. And then what we take forward from that, again, this won't be generated because we didn't have all of the previous answers, but we generate a de-risking strategy. So we identify some of the key things that you need to do in order to de-risk the development of your technology, and we'll give you a final report which summarizes everything that we've generated for you with data, with references and everything. So it kind of is like the equivalent of a consultancy report. And then finally, we've got our business development features that we've been building over this week. So we probably, for the sake of time, won't go through every single step, but just to say that we've made a similar pipeline to be able to address the business needs and really develop, turn a technology into a viable business. So if we just open up, for example, market and customer research, we identify relevant target markets, list them out for you. You can pick up to 3 of those to explore in more detail. And then when you're happy, you'll hit the next step, and we'll actually go and do market analysis for you. So these, again, using deep research AI tools, we'll work out the market size, the growth rate, some of the key highlights from the literature on these markets, maybe some key characteristics, some trends. We're also doing sentiment analysis and SEO analysis as well to see what people are searching with regards to these different markets. So there's a lot of data to be evaluated there. Once you're happy, you can select one of the markets that you want to take forwards. And then it will actually do a segment analysis. So it will break down that market into different segments. And then you can see you've got a lot of detail on the different segments. You can then just pick one of those segments. It will then generate for you a customer persona. And so this is just one example. But yeah, it like humanizes the kind of customer in this case. So you can see them in virtual life, I guess, and imagine that they're a real person with needs that you're trying to serve. And so you get to understand more about their pain points, their psychographics, what motivates them, et cetera, which obviously helps you then tailor your business towards them. We haven't actually built this yet, but we're also going to be integrating with some of the big company database pipelines. So things like Crunchbase, for example, we want to be able to automatically generate a CRM. Once you know your customer persona and you know your target market, we should be able to automatically generate a CRM for you. So with all of this in mind, you can see that, I mean, first of all, we're obviously doing a lot of the heavy lifting of turning a research into a business. Of course, there's various optimizations to be made at every stage. But yeah, we're really trying to make this process less scary, more systematic and more predictable, and of course faster as well. Like we're able to do these things in a matter of minutes, not hours, not weeks, not months, as some of this typically takes, and really just give people the fuel to be able to turn an idea or something that they're working on into something that they could actually go and pitch to an investor at the end of the day, raise some money, and actually try and build a company around it. So yeah, that is the summary of what we've been up to, what we've got in the future, or at least the next few weeks. We want to turn this into an iterative process. So right now it just runs like one run for each thing, but we want it to basically update, learn each time, and then just run it multiple times so that this AI agent can basically learn with you about your project and get better and better at helping you through all of the business challenges that you might face. And that's all.
Wow, I think that's absolutely incredible. Thank you, Morgan and Gunjan. There's a few questions in the chat from the audience. I'll start off with one of my own where maybe it's observation where this could be like a necessary tool for anyone trying to propose ask for funding from Valley DAO or other DAOs. But conversely, if there is an application that isn't well researched, people could use this for like more due diligence and research into a funding idea or like a research idea. So yeah, I could see it'd be super useful for both sides. Vince asked a question about how it could be used by experienced biotech operators versus maybe people more new to the space. It looks super useful for either time saving or like one way to use AI is you give it an example of 3 things that you know, and then you ask it for like 10 more things. And it seems like it could be like time saving in that way, even for an expert.
Yeah, we're over the next few weeks, we're going to onboard some very hopefully prestigious testers who are going to put it through its paces and really tell us, where can it do better in terms of the scientific research that it's doing. Because yeah, I mean, it's probably going to surface a lot of the knowledge that experts already know. But given the automation capacity, we want it to be able to surface things that maybe they didn't think about, and maybe touch on literature that they haven't yet read, or bring new suggestions from other fields that maybe could work in that case. So we have a lot of ambitions for this, but we want to obviously get the basics down first.
Yeah, Juan asks, can we expect or imagine a research where it'll prompt the system to conclude, or basically a negative case where there's not a route to a business yet, or is it always going to explain like a possible route to a business?
Yeah, so that's a great question, and something that we definitely don't want. So one of the things that we're doing at each step is we're not just giving positive signals. We want to identify risks, challenges, things that would suggest. Oh, sorry, I could feel that coming. Things that would essentially suggest that your idea is actually not viable. So, for example, when we do the scientific research, one of the primary things that we're asking in the beginning is what would mean that this could not happen, or this is not physically possible? Are there any contradictions in the literature? Are there any things that suggest this is outside the realms of physical possibility? And so the questions that it will ask are really trying to, rather than make your idea, they're also trying to break your idea at the same time. And of course, if it cannot break your idea, then it means it's within the realms of possibility. And you should just go and ask those questions. But the first and foremost thing that it will do is identify what are those like 2 or 3 key experiments that you need to know the answers to that will make or break your idea. And of course, it cannot give you those answers if they don't exist in the literature already. That's up to you as a researcher to go and put the liquid in the tube.
Yeah, it looks super useful to me as a way to even help get through the idea maze of a startup or a new process, a new experiment where it raises questions that you'd have to answer or the project wouldn't work out. Another question from Vincent. What are the evals that you're using to build conviction on the accuracy of the more quantitative dimensions of the generated outputs, like the hard numbers and the estimations?
Yeah, it's another great question. So at this stage, we haven't gone any further than human due diligence. And what I mean by that is we're assuming the AI can act on the level that a collaborator or a consultant could work. So they might go out and find information, present it to you. it's up to you as the receiver of that information to do your own due diligence and decide whether or not you want to use that. So one of the things on the first iteration of this tool is like everything was just kind of black box run right through to the end. What we now added, even last week actually, was this whole verification process so that you could actually go through the results, look at the sources that it's cited, see where all of the evidence and inference is coming from, and make your own evaluation about whether or not that's trustworthy. Maybe there's some sources that you think the papers are a little bit bullshit. Like, of course, you know, these agents are trained on or they're using publication data. Publications aren't always trustworthy. So you need to be able to have that granular level of control to say, I don't trust this paper, or I don't trust this person. Therefore, I don't want their results showing up in my answers. But in terms of like programmatic evals, yeah, not so much. We're giving the user kind of a lot of flexibility to do their own due diligence on that. But yeah, I mean, I'm open to suggestions on this and like ways in which we can automate that. I think I'm a little bit skeptical at the moment, but yeah, I'm happy to be proven wrong.
Yeah, there's some comparisons to an existing bio protocol project that we have called the Portal, which helps like a new DAO, like a new bio DAO, go through the steps necessary to basically construct the DAO operations and the social apparatus to actually have a new bio DAO be funded. But this seems like a perfect complement where it helps on the research side as well. So looking forward to watch it develop it and talk to you further about it. I think we'll have a few minutes left, so we'll wrap up. Thank you, Morgan, Siddharth, and Stanley for your presentations. We have basically a few announcements. We have a little over 3 weeks left in the hackathon. I'm gonna just put the Devfolio link here again for anyone. Please share it with your developers. Like there is still time to develop something that would be a good submission and win a prize. So it's not too late to join the hackathon or share it with your developer friends. We'll be I'm based in New York City, and so there's a Solana hackathon, Solana conference happening next week, and we'll be there presenting about VitaDAO, Bioprotocol, and the projects here at a DeSci Science Fair, which is on the 20th. If anyone's around New York City or has friends here, please come by. And lastly, the wrap-up event is happening on June 10th and 11th in Berlin. We'll have the hackathon submissions and presentations live in Berlin. So save the date. That'll be June 11th. Yeah, and Eric shared the Discord link. It's critical that you join the Discord if you're part of the hackathon. And yep, thank you, it's right there. And with that, Eric, any closing words, or you can wrap it up here?
Just wanted to say thank you everyone for joining the stream, and thank you all the hackers for the amazing work you're doing.
Thank you, and we'll post the links to connect with Stanley, Siddharth, and Morgan in the Discord for follow-up questions.
Thanks for putting us on.
Yep. All right, guys, we'll close it here. Have a great day.